Today we'll start the new chapter, chapter number 13, that is magnetic effect of electric current. Okay, that is the magnetic effect of electric current. And we know that the magnet and current both are interrelated to each other. That means that magnet and the current, electric currents are interrelated. These two has a relationship. Okay, but it's very confusing for you all, no, that how हामीलाई confused लाग्छ नि हैन, how this magnet and current are interrelated. That means यो दुईटा चाहिँ कसरी interrelated छ भनेर. But not only for us, it's confusing for the scientist also. Scientists लागि it's very confusing. And so after doing so many experiment that Hans Christian Ostrich has come in the end. So many scientists experiment गरेर at the end who proved that magnet and current both are interrelated भनेर चाहिँ कसले prove गर्नुभएछ? That is the Hans Christian Ostrich in the year 1820 मा. And the experiment is called Ostrich experiment. Clear? Ostrich भन्ने scientistले उहाँले चाहिँ he has proved that magnet र current चाहिँ के छ भनेर that two are interrelated. Clear? Magnet त्यहाँनिर current flow हुँदैछ भने there will get the magnetic field also, magnetic effect also भनेर who proved that the Hans Christian Ostrich has proved. Clear? Now what he did, that means we'll do the experiment how he proved. कसरी उहाँले prove गर्नुभयो. For that he has taken the conductor wire. We know in order to pass through the electric current we need the conductor, isn't it? हामीलाई conductor चाहियो नि. Conductor, suppose look at here, we have taken the copper wire. Clear? हाम्रोमा के छ रे copper wire and connect that copper wire with the battery. Clear? के गर दुईटा copper wire को दुईटा end लाई connect it with the battery. As soon as we connect this battery with the copper wire, के हुन्छ भन्दा चाहिँ that battery हामीले जोड्ने बित्तिकै it start that current flowing through the copper wire. Battery जोडे we call the cell. जब हामीले त्यो cell जोड्यो भने के हुन्छ, automatically the electric current passes through that copper wire. Clear? Pass हुन्छ. अब how हामीले कसरी चाल पाउनु? There is magnetic effect also. Magnetic field पनि छ नि, how we identify. And we know that in the previous chapter we all know that the device voltmeter which measures the potential difference, isn't it? And the ammeters measures the electric current. And likewise we have one device that is compass needle. Clear? Compass needle device which measures the magnetic effects. के measure गर्दछ that compass needle magnetic effect. That means usually यो compass needle it is used for navigations. Ships को navigations को लागि to find the way, बाटो खोज्नुको लागि the sailors were used. Clear? till उहाँले use गर्नुहुन्छ. And it is also used the directions to find out the directions. अनि यसले अर्को के पनि detect गर्दो रहेछ whether there is magnetic effects or not. Clear? अनि अर्को के गर्नु पर्यो हामी, मैले भने the battery or the cell is connected with the copper wire. जब copper wire मा अब त्यसलाई हामीले connect गरेपछि that passes through the electric current flow हुनु थालिहाल्छ. अनि जब तिमीले त्यो needle compass needle छेउमा लान्छ it shows the deflections. Deflections भनेको त्यो बीचको काँटा हल्लिन्छ. In the needle, just look at this needle. अब यो needle मा हेर त, here will get the two. एउटा चुच्चो end छ, एउटा मुनिको end. Sorry, एउटा arrow छ, एउटा मुनि छैन. And that arrow part is called the north pole. अनि arrow को मुनिको part लाई we call south pole. क्लियर अनि जब तिमीले त्यो निडल चाहिँ छेउमा लाँदा त्यो ब्याट्री कनेक्ट वायर कनेक्ट गरेको सेलको छेउमा लाँदा इट सोज द डिफ्लेक्सन सोज डिफ्लेक्ट भयो भने वी क्यान से दैट देयर इज म्याग्नेटिक इफेक्ट also. Clear? That way that ostrich has proved his experiment. Clear? Now next we'll have important term, that is the magnetic field and magnetic field lines of forces. We have the two terms, and first we will do the magnetic field. Actually, what is this magnetic field? And it's nothing, in the physics word we can say area around the magnet in which magnetic field is experienced. It's a area around the magnet. Clear? And we called it a field of a magnet. It's a field of the magnet. That means where it will attract or repulse the objects. कतिको डिस्टेन्ससम्म एउटा म्याग्नेटले कतिको डिस्टेन्ससम्म चाहिँ अब्जेक्टलाई एट्र्याक्ट गर्न सक्छ र रिपेल गर्न सक्छ, त्यही एरियालाई चाहिँ वी कॉल द म्याग्नेटिक फिल्ड, उसको जग्गा, उसको एरिया. क्लियर? नाउ दैट इज द म्याग्नेटिक फिल्ड. नाउ नेक्स्ट विल हैव म्याग्नेटिक फिल्ड लाइन्स अफ फोर्सेस. व्हाट डज दिस? नाउ इट्स नथिङ, इट्स बेसिकली इट्स अ इमेजिनरी लाइन्स drawn around the magnet. Magnet को वरिपरि draw भएको imaginary lines, त्यसलाई नै we called magnetic field of, that is the magnetic field lines of forces. Clear? अब यसलाई चाहिँ another thing how you'll understand this, just look at here. This is magnet and यहाँ the magnet को this is the field lines. This is imaginary हुन्छ, जुन चाहिँ हामीले देख्दैन. क्लियर? तर that lines exist. मैले यहाँनिर देखाएको छु यस्तै लाइन फर्म हुन्छ तर हामीले देख्दैन, but this imaginary line exists in the magnetic field lines मा. क्लियर? अनि यसले चाहिँ के गर्छ, magnetic field lines ले determines polarity of north and the south pole of a magnets. अब यो चाहिँ के determines गर्दैछ यसले, it's a polarity of north and the south pole of a magnet. Okay, before that I'll let you understand what is magnet first. Okay, recapitulate we'll do what is magnet. Actually just look at here, this is the magnet. It has two sides, north pole and the south pole, and this north pole is called north polarity and the south pole is called south polarity. Just look at here, we'll get the imaginary lines, and always this imaginary lines, it forms from the north pole and it will start from the north pole and ends at the south pole. That means जहिले पनि यो लाइन कहाँबाट स्टार्ट हुँदो रहेछ, it start from the north polarity, north pole बाट, अनि कहाँ गएर एन्ड हुँदो रहेछ, साउथ पोलैरिटी, साउथ पोलमा गएर एन्ड्स हुन्छ. क्लियर? दैट यू हैव टू रिमेम्बर. क्लियर? अनि जस्ट टू अंडरस्टैंड बेटरली विल डू द एक्सपेरिमेंट. क्लियर? Suppose you just take a bar magnet, you all have understood no what is north pole and the south pole. That means the magnet ko duipati ko sides, it's in the one side will get north pole and in the another side will get south pole. And another thing we know, हामीलाई याद छ north pole तिमीले छेउमा लाँदा it will repel each other, and the north and the south pole, if you bring that together, that too will attract towards. That means you have to remember this thing. And here in the magnetic field lines of forces ma pani, this determines the polarity of north and the south pole of a magnet. अनि हामीले अर्को के पर्यो, always that imaginary line start from the magnetic force of line, that is they start north pole, start magnetic field of lines, अनि magnetic force of line चाहिँ कहाँ गएर एन्ड हुँदो रहेछ, नर्थबाट स्टार्ट भएर साउथमा गएर एन्ड हुँदो रहेछ. क्लियर? अनि अब जस्ट एक्सपेरिमेन्ट लागि टेक अ स्मल कम्पास एन्ड अ बार म्याग्नेट. के तिमीले एउटा कम्पास लियो, सरी बार म्याग्नेट लिनु अनि बार म्याग्नेटको माथि किप वान कार्डबोर्ड on the bar magnet and sprinkle some iron fillings. Iron fillings भनेको चाहिँ आइरन को टुक्रा क्लियर हामीले पाउँछ will get in the labs okay अन्त त्यसमा हालेर you'll just observe मुनिपट्टि के राख्नु बार म्याग्नेट माथिपट्टि कार्डबोर्ड माथि you place some sprinkle some iron filling तिमीले छोड्दिएपछि automatically that will place in such a pattern. Just look at this यहाँनिर हेर यस्तो प्याटर्नमा फर्म हुन्छ अनि व्हाट डिड यु अब्जर्भ हामीले के अब्जर्भ गर्दैछ डेन्स नियर द पोल्स हेर त पोलमा चाहिँ जम्मा हुँदैछ बट के हुँदैछ रेयर एट द मिडल इजन्ट इट बीचमा चाहिँ रेयर छ त्यति आइरन फिलिङ जम्मा भएको छैन अब यहाँबाट चाहिँ हामीले what we observe is that the magnetic field of force are dense near poles. Magnetic field को the force चाहिँ केमा बेसी हुँदो रहेछ भनेर चाल पायो magnetic effect is high at the pole. Clear? And number 2 मा we observe that magnetic field of force are rare while moving away from the poles. Poles and टाढा गयो भने magnetic effect के हुँदो रहेछ लो हुन्छ भनेर will identify with this experiment. Clear? अनि हामीले बुझ्यो magnetic field lines of forces actually it's a imaginary line भनेर which त्यो चाहिँ के हुन्छ imaginary line हामीले देख्दैन but that line exists भनेर. Clear? This is the two important points.